Dear students, let's see chapter 2 of maths, that is polynomials. So, what is a polynomial? Let's see to it. The word polynomial means an algebraic expression consisting of one or many terms involving powers of the variable. If we split the term polynomial, we get poly and nominal. Poly means many and nominal means terms. So simply if we say it's an expression consisting of many terms. Now let's have a brief idea of an algebraic expression. An algebraic expression in mathematics is an expression which is made up of variables and constants along with algebraic operations such as addition, subtraction, multiplication, etc. Let's take an example of algebraic expression. Oh, it's an example. 5x cubed minus 4x square plus x by 2 plus 3. This is an algebraic expression consisting of terms and algebraic operations, that is pluses and minuses. Let's take the same example, that is 5x cubed minus 4x square plus x by 2 plus 3. In this algebraic expression, we have four terms, which are first 5x cubed, second minus 4x square, and third is x by 2, and fourth is 3. So all these four terms makes up this expression. Now let's take one term, say 5x cubed. So what does this mean? This 5x cubed is a term, which means 5 into x raised to the power 3. So a term should consist of three things or three components. What are those? Let's see to it. It should consist of a number, which is called a coefficient. Then it should consist of a letter, which is called a variable. Then this variable is raised to a power, which is called an exponent. So every term should consist of these three things. It will have a coefficient which will be multiplied by a variable, and the variable is raised to a power. Now let's see the condition to make an algebraic expression into a polynomial. It's because every algebraic expression is not a polynomial. There is a certain condition to that to make an algebraic expression into a polynomial. Let's see to it. Following are the conditions. In case of coefficient, that is the number, there is no any particular condition. Coefficient can be any real number. It can be 5, it can be 6, 2, it can be minus 5, it can be minus 10, and it can be fraction 1 by 2, it can be 3 by 4, anything. Now in case of variables, also there is no any particular condition. It can be any variable. It can be x, it can be y, it can be g, it can be t, anything. And also there is no limit in the number of variables. It can be single variable, it can be two variables, it can be three variables. Now comes the important condition which makes an algebraic expression into a polynomial. That is in case of exponent. An exponent must be a whole number. That is, it can be either 0, 1, 2, 3 and so on. So this exponent should be a whole number. It cannot be any other number. It cannot be any real number or any negative number or any fraction. It should be a whole number to make an algebraic expression into a polynomial. Let's see the expression which we were discussing is a polynomial or not. This expression, that is 5x cubed minus 4x square plus x by 2 plus 3. If we see the exponent, all the powers, all are whole numbers. So obviously this expression is a polynomial. As we have seen that an exponent can be any whole number, that means it includes 0 also. So what will happen if the power or the exponent, that is this power or the exponent, is 0? Say if we take the same term 5x cubed, if we replace 3 by 0, so 5x raised to the power 0, we get 5. This is known as constant polynomial. That is, it does not have any variable. How it's possible? It's because x raised to the power 0 is always 1. So 5x raised to the power 0 is 5. That is, 5 into 1 is equal to 5. Or we can say 6 raised to the power 0 is equal to 6. Or we can say 9 raised to the power 0 is equal to 9. Now let's also see one more thing. We have seen that the coefficient, that is this coefficient, can be any number, can be -5, 2, 1 and 0 also. If this coefficient is 0, so what will happen? So 0, x raised to the power 0 will be 0. This is also a constant polynomial, but it is known as zero polynomial. Here, few algebraic expressions are given. Let's see which algebraic expressions are polynomials and which are not. Let's take the first expression. X square plus root 5x plus 4. In this expression, all the exponents, or we can say powers, are in whole numbers, that is 2, 1 and 0. So these are all whole numbers. These exponents are all whole numbers. This expression is a polynomial. Now let's take the second expression. 3y square plus y by 2 plus 4. In this also we can see that the exponents, the powers, are in whole numbers, 2 and the 1 and 0. So all are whole numbers, all the exponents are in whole numbers. So this is also a polynomial. Now let's take the third expression. 3x cubed plus 2 root x plus 1. It's something fishy. In this, in the second term, we can find root x. The root x means x raised to the power 1 by 2, which is a fraction. So an exponent cannot be a fraction. It should be only a whole number. So this algebraic expression is not a polynomial. Now let's see the fourth expression. 2y square plus 2 upon y. So here also something fishy. In the second term, which means 2 into y raised to the power -1. So here also the exponent is -1, a negative number, a negative exponent, a negative power. So it is also not a polynomial. But let's take the last expression. X raised to the power 10 plus y cube plus t raised to the power 50. In this, all the exponents are in whole numbers. So this expression, or this algebraic expression, is a polynomial. Now let's see one more thing in these cases. In the last case, we can see that we have, in this expression, we have three different variables, that is x, y and t. So this polynomial, we can say, is a polynomial in three variables. In above two examples, or above two cases, that is this one and in this one, these are polynomials in one variable. Now let's see the degree of polynomial. The degree of polynomial is the highest power of the variable in a polynomial. It is the highest power of the variable in a polynomial. So what does this mean? Let's take an example. We have taken the same old example, that is 5x cubed minus 4x square plus x by 2 plus 3. If we see the exponents or the powers, we have 3, we have 2, we have 1 and 0. So in this expression, or in this polynomial, the highest power of the variable is 3. So the degree of the polynomial of this expression is 3. Let's take another example. 9x raised to the power 4 minus 6x cubed plus 4x square minus 2. In this also we can see the highest power of the variable, that is x, is 4. So the degree of polynomial of this expression is 4. Now let's take another example. 7. 7 is also polynomial, that is constant polynomial. Here it means that 7 x raised to the power 0 is equal to 7, as we have seen in the earlier case. So the degree of polynomial in this case is 0. Now let us classify polynomials on the basis of terms and on the basis of degree. First, let us classify it on the basis of terms. So if we see a polynomial, if a polynomial has one term, it is known as a monomial. That is, it only has one term. If a polynomial has two terms, it means it is a binomial. For example, x square plus 2, it has two terms. If a polynomial has three terms, it is known as trinomial. For example, x cube plus 2x square plus 2. In this case, there is three terms, x cube, 2x square and 2, and this is known as trinomial. Now let's classify it on the basis of degree. If the degree is 1 or the highest power is 1, then it is known as linear polynomial. If the polynomial has degree 2 or its highest power is 2, then it is known as quadratic polynomial. For example, x square plus x plus 3, here the highest power is 2, or we can say the degree of this polynomial is 2. So it is known as quadratic polynomial. Now, if the degree of the polynomial is 3, then it is known as cubic polynomial. Here in this case, we can see 3x cubed plus x square plus 1. In this case, the highest exponent, or we can say highest power raised of a variable is 3. So if a 3 is the degree of a polynomial, then it is known as cubic polynomial.